Hello all, today we discuss about basic read-write operation in random access memory. So read and write operation perform in read-write memory or ROM. So basically it is known as the memory concept. So first of all, what is memory? Basically memory is a array of register. This is the first thing, okay? So array of register means the number of register, and the number of register is and the number of register determine the size of the memory, okay? So first of all, let us consider this is a m number of register and each register n bit. So therefore the size of the memory is m cross n bit, okay? And also known as it is mentioned as a byte from also. So basically what is the thing? The thing is that in a memory basically there is an array of registers, okay? So just consider here only one register named as R, and the register is 8 bit wide from D7 to D0. So each bit in a register is represented by a D flip-flop, or also known as parallel input parallel output operation. Basically this type of register basically used in the type of parallel input parallel output operation for the first processing operation and to get the data and to write the data in from memory or to the memory, okay? So that's why this PIPO concept is very important rather than PISO, CISO and SIPO concept. So this is very important to study the individual bit. So how individual bit and read and write facilities are available in a memory. So just look here, this is one D flip-flop, here positive edge clock, here one tri-state buffer is connected in the input and also in the output. So this pin is known as write bar and this pin is known as read bar. So here we apply the input and here we apply the output and here we apply the clock signal. So now there is some algorithm steps by which we can enter this number here and output the number from here. So when at first we apply the input equal to 0 or 1, any one, number 2, write bar signal goes to 0, because if write bar signal goes to 0, then the data which is applying in the input D input 0 or 1, this data is coming out here, okay? Now number 3 step, we apply the clock signal, we apply the positive edge clock, and this positive edge clock, at this positive edge of the clock signal, the data is coming out here but not here because read bar pin is no action. Now in the 4th step, the read bar pin goes to low and therefore the output equal to 0 or 1 respectively. So this is the 4 basic steps to read and write operation in any D flip-flop. So array of this D flip-flop make and register. So if we design array of this register, so if we make the array of this register, so just a minute, this array of register, this 4 bit or 8 bit. So this array of array of register, say there are 8 D flip-flop are available. So these 8 flip-flop are basically represent the individual data bit D7 to D0, and all pin are internally connected via each individual blocks like a read bar, write bar, D input, D output, etc. So that's why the read and write operation are performed in the register array or memory concept.